Hi, in this comprehensive course of indefinite integrals, now we are in last stage, that is now we are going to discuss integration by parts in last two lessons. So this is the first part on integration by parts, that is lesson number 21. So let's get started. So the integration by parts will be applied. This is a technique we apply whenever we see the integrand as a product of two different functions, and especially the product of two different functions means that the functions are of different natures or different definition. Like you see that this is the function, the entire function is the product of two functions, that is x and sine x. So we can understand that x can be supposed as the algebraic function and the sin x is actually the trigonometric one. So in order to do that, there is no such product rule to find the product of the integration of product of these two functions. So we have a new technique or another technique which is called integration by parts. So the formula to evaluate the integral is what? Suppose I have two functions u and v and both are functions of x. So the integration of ub dx will be given as u times the integral of v and minus the integral of the derivative of u times the integral of dx, and this is actually the whole thing we have to integrate here. So this is the formula. You can observe what is the pattern we have to follow in it. And now the main reason and the main concept here, that how can we decide that which is u and which is v, because it is not mentioned that while you are solving any question or doing an integration, it is not mentioned or not given to you that u is x and v is sin x and vice versa and all. So you have some technique or you have some reasoning behind choosing the appropriate u and appropriate v. So especially you understand that we choose the function as u whose integration is not possible, or sometimes we find the integration is difficult. So actually here it is not the case, because x has this, the integral easy and sin x also can be integrated easily, but in most of the time you find that u should be taken as though that function whose integration is actually not possible or whose integration is we find difficult. So let us understand how can we opt the u and v. So there is a rule of ILATE, and it is the rule to select a function as u. So you see the I stands for inverse. So the inverse function is like sine inverse, s cos inverse, etc. Similarly, L is for logarithmic functions, A is for algebraic function, and T is for trigonometric function, and E is exponential function. This is the order. So the functions or the set of functions at the top should be preferred for you. So let us try to understand it with an example, or let us try to understand this from the previous example, that is x sin x. So you can see that x is algebraic and t is trigonometric. So if you follow the ILATE rule here, you can see A is before trigonometry, so the algebraic should be taken as u and the trigonometric should be taken as v. Alright. Now let us apply this thing into doing this example again. So this is x sin x, so you should take u as x and v as sin x, of course, and you know the integration will be done by this formula, that is u times the integration of v and the whole integration of this function, that is u dash times the integration of v dx. And so u is x and the integration of sin x will be done, and again the derivative of u should be here, so I have done the derivative, that is 1 for x, and similarly we have to write that v is equal to sin x, and now we are going to integrate this sin x, that will be negative cos x. And of course here the integration of sin x will be again negative cos x. So let me erase it, I have done a mistake I think. Alright, so okay, it is not going to happen. Alright then, no problem. So I will just, okay, so this will be negative cos x, sorry, so this will be negative cos x again, and then you'll integrate this cosine x, that will become sin x. So the final answer will be negative cosine x, sorry, negative x cosine x plus sin x plus c. Alright, so this is the way to find the integration, find the integral of any given integrand by the help of integration by parts. Let us do this example. Here you can see the e to the power x times x square is given. So if you use the isolate, you can see clearly that e is exponential, and here x square is algebraic, so u will be x square, because algebraic comes before exponential in this isolate sequence. So you see that u times v dx, and the derivative of u, and again the integral of v and the whole integral. So you will get x square e to the power x minus 2 times x e to the power x, because when I integrate this e to the power x, you will get e to the power x again, and since you can see that x times e to the power x dx will have the same nature what we can done by the isolate process again. So here this x is again taken as first or u, or e to the power x as second or v, and we are applying this integration by parts once again. So this is what x times integration of e to the power x and minus the derivative of x and so on. So you have to just take care this, as this is done within the big bracket, because this 2 is multiplied with the result of this integration. So you have to keep this 2 before this big bracket, and you are going to just simplify it further, and you will get x e to the power x minus integration of e to the power x, and that will be the final answer again. So you can see that in some questions the iterated integration by parts should be done, and we have to do the integration in this way. Let us take this example. Here you can see that the iteration was over at that second time, because after that you can see that all the functions are actually done with the integration, but sometimes the iteration will not stop. So let us see how we can handle that situation. So suppose I have this integration e to the power x sin x. So of course sin x will be u or first, and e to the power x is v, and in this sin x times integration of e to the power x, and again cos x times integration of e to the power x, the whole integration. And the integral of why I am writing here cos x, because the derivative of sin x we have to write here, and this is what now cos x e to the power x. You can see again that it is again demanding the integration by parts, so we will do that. So here this cos x can be taken as first and the e to the power x as second or v, whatever you assume. So this will be cos x e to the power x dx minus the derivative of cosine x is negative sin x, and the integral of e to the power dx, and so on. So again we are putting a big bracket here, the curly bracket, and we will get e to the power x cosine x, and again this thing. So you are getting that this sin x e to the power x is again demanding the integration by parts, but you can simply foresee that if you again integrate it, you will get the same pattern, and you are not going to end anywhere. So what we can do, you can simply open this bracket, and you will get three terms, e to the power x sin x, minus e to the power x cosine x, and the term which has to be integrated, and that is what the integral of sin x e to the power x dx. So you have to integrate this entire term, and you can see clearly that it was the original function we have started with. So this can be replaced with I, because we have assumed that the integration of this thing is I. So this is actually one of the reason that we should always write I before we start integrating. So again, this can be replaced with I, and so and also we can add an extra term c1, because we have to add this constant at the end. So this negative I and this I in the left hand side will get added, and this will become 2i. And remember, we had to find I, so we should divide with 2, and we will get this c1 by 2, and c1 by 2 can be written as a new constant c, and here we will get this one. Again, you can take this e to the power x by 2 common to make it more good in appearance, and that's all. So that is the integration. So you can see in some questions there is a direct integration. That means the integration will happen in the first step, as we done in the first example. In the second example, we have done that the iterated integration will be done, means integration can be done twice. Integration by parts can be applied twice, and the integration will get over. But sometimes integration will never stop. So for that we have to integrate up to that stage where the I can be found somewhere in between, and from there you have to do the algebra and find the I. Now this is a unique kind of integral. This is a popular one, that what is the integration of ln x. So the integration of ln x is not done directly, cannot be done directly, because this is the function we don't for this we don't know the exact integral. If you simply observe that whatever function we have learned in our syllabus, that is whether it is a trigonometric function or exponential function or any algebraic function, we know more or less their integration. But for this very basic function, that is logarithmic function, we don't know the integration, and the integration will be done by the integration by parts. So let us understand how we can deal with. So you can see that the integration by parts will work only if there are two functions in product. So here we are not seeing any two functions, there is a single ln x. So what we can assume, since 1 is multiplied to every number or any function, we can assume that 1 as a other function. And if you follow the ILET rule, you will see that logarithmic will be first and algebraic will be second. So of course 1 should be taken as the in algebraic, and log x is logarithmic, of course. So you will take u as ln x and v as 1. So the integration by parts will be done by the same formula, that is the u times the integration of v and the derivative of u and the integration of v and the whole integration. And so this is what the integration of 1 will be x, and so x and x will get cancelled, and this time the integration of 1 will be x here. So we will have the final answer as x ln x minus 1. So you can always remember that the integral of ln x is x ln x minus x plus c. So this is the integration by parts we have done. In the integration by parts part 2 video, in the next lesson we are going to see some other stuffs related to the integration by parts. Thanks for watching.